here is where we're trying to prove that this is a rhombus, guys. You have two options, so I kind of just showed the solution so I can have it on the same page. But again, a rhombus, think about what we learned in class. We actually did an example like this where we're proving it's a rhombus. You got to prove that all the sides are equal. I will say that sometimes distance formula could be a little bit easier than trying to sketch your triangles, but you can also sketch your triangles. If you choose to use distance formula, then again, you're going to come down and, figure out what is your distance formula first and foremost. So if you're using distance formula, you're going to say your x2 minus x1 squared plus y2 minus y1 squared. All right, and so then this is equal to, let's say, ON. And so you're going to just plug in those points for ON, and that allows you, so for O, I'm going to let O be my x2, right? So let me scroll up. O is at 9, 5, right? So I know my O is at 9, 5, and my N is at 3, -2. And so if I know that, then I can come and plug those in. So my two x's, I'm going to say 9 minus 3 squared plus my y's, which is 5 minus a -2. So squared as well. All right, guys, so now that I have that, I'm just going to keep simplifying. So 9 minus 3, that gives me 6 squared minus 5 minus a negative. So that's going to be 5 plus 2, right? So I'm going to say minus 7 squared. And so here, well, 5 plus 2, yes, so that's going to be plus. All right, so 6, that's going to give me 36 plus 49, right? And so 36 plus 49 is going to give me square root of 85, right? And so square root of 85, and now I can take this and I can, again, simplify, or I can move on to my next one as well. So ON is at square root of 85. Now, I do think the distance formula, especially on these problems, may be a little bit more easier than trying to do the triangles, but you are welcome to do your triangles as well. So now I'm going to start on finding the length of the other side, right? And so I can find the length of MP, right? And so I can take the square root, look at where are M and P. They tell me M is at -6, -4. They tell me P is at 0, 3. And so I'm able to plug those things in, right? So I need to subtract my x's. So I'm going to say -6 minus 0 squared plus -4 minus 3 squared. And so then I'm going to simplify down. I get -6 minus 0. That's going to give me 6 squared plus -4 minus 3. So -4 minus 3, that's going to give me a -7 squared. And so here I have 6 squared plus 6 squared give me 36. That gives me 49. 36 plus 49, that's going to give me another square root of 85. And so I know MP is square root of 85 as well. Now, again, you can keep this process up. I know now the MP, and I also know ON. So those opposite sides are equal. Now I just need to look at the other sides. And so you would do that, guys. And so, again, you would put it in distance formula if you choose and see that all the sides are equal to the square root of 85. And so, therefore, all the sides are equal in measure, and therefore, it is indeed a rhombus. So the way to prove a rhombus is the way to prove a quadrilateral is a rhombus is to just verify that all sides are equal in measure.